This is problem number 3 from the sample test problems for test number 3. Solve the equation cosine of 2t equals sine of t minus 1 for 0 less than or equal to t less than or equal to 2 pi. Show all algebraic steps. Hint, use a trig identity. Okay, so that bold phrase there means don't just graph the two sides of this equation on your calculator and then intersect them, although we'll do that to check our answer at the end, but rather do everything with algebra. Okay, so use a trig identity. On the left-hand side, we have cosine of 2t, and on the right-hand side, we have sine of t minus 1. What makes this challenging? A couple of things. First, there's sines and cosines in the same equation. Second, the angles are different. On the one hand, we have an angle of t. On the other hand, we have an angle of 2t. And those don't really work so well together. So ultimately, we'd like to get them to be the same angle. So cosine of 2t on the left, I'm hoping you remember there are a few different identities we have for cosine of 2t. Cosine of 2t is cosine squared t minus sine squared t. It is also 2 cosine squared t minus 1. And then finally, it is also 1 minus 2 sine squared of t. I don't need you to memorize these. You'll have them on the reference sheet that you bring with you to the test. So which one should we pick? Well, look at the right-hand side of this equation. It has sine t. This trig function involves two different, that top identity involves two different trig functions. This one involves cosine. This one involves sine. Let's pick the one that involves sine to match up with the sine that we already have. So, rewriting the left-hand side using our identity, instead of cosine of 2t, we're going to put 1 minus 2 sine squared of t. And then we're going to copy the right-hand side of that equation. So just replace the left-hand side with our bottom identity, copy the right-hand side. Okay, I see a sine squared, I see a sine. It feels quadratic. And if it's going to be a quadratic because of that squared, then we want one side equal to 0. Let's bring everybody to the right-hand side. 0 equals. So we had minus 2 sine squared. Add it to both sides. It becomes plus 2 sine squared. On the right-hand side, we already had sine t. It doesn't change. And then on the right-hand side, we had minus 1. We're going to subtract the 1 from the left-hand side as well. So subtract 1 from both sides, and it becomes minus 2. Okay, this is a quadratic. If you imagine letting y equal sine of t, then this equation becomes 0 equals 2. Sine squared is really y squared, plus sine is really y minus 2. So I don't need you to do that substitution, but if you are more comfortable dealing with it this way first, that's fine. Either quadratic formula, or if we're lucky, this thing factors. Does this thing factor? Okay, so I was hoping, I paused the video there just to check the answer key. I was hoping it factored, but sure doesn't look like it does. So if it doesn't factor, then we must use the quadratic formula. So let's give that a shot. So we're doing the negative b plus or minus square root of b squared minus 4 times a times c. 4 times 2 times 2. And that's divided by 2 times a. 2 times 2. Negative 1 plus or minus square root of. One of these two should have been negative in the parentheses here, or in the radical, I should say. So that's a 1 plus a 16, that's a 17, divided by 4. All right, so this is what we're after. And instead of y now, we'll finally go back and say, well, it wasn't really y, it was really sine of t. So let's bring that back over here. Sine of t is equal to negative 1 plus or minus the square root of 17 over 4. All right, certainly we're going to use our calculator to solve this by doing an inverse sine on both sides. So all this stuff is going in there. And normally I would just type this all in as one shot, that inverse sine included. But I want to I'm going to type in just the thing circled in green for a second. So -1, I'm going to do the minus radical 17 first. And that's divided by 4. And we get -1.28. Fine. So what we're trying to do here is say that sine of t is supposed to be -1.28 on the one hand, and it'll be a different number when we use the plus. But I'd really like for you guys to be able to look at that equation, sine of t equals -1.28, and say something. What kind of an angle can you plug into the sine function and get -1.28? The answer I'm hoping you see is that there isn't any, because sine is always trapped between +1 at the top and -1 at the bottom. And there's no way for us to get a value of -1.28 as the output for sine. It's okay if you don't do that calculation separately. If you had asked the calculator naively to find the inverse sine of the answer, well, it would have given you an error. It's a domain error because you can't plug in anything more than 1 or less than -1 into the inverse sine. So that one we can ignore. Go ahead and erase this thing here. And the only one that's going to make sense for us is going to be the plus. So let's try that. So I'll do second entry a couple of times. Oops. Second, enter, to get back to that line. But now we want to do -1 plus. We're hoping to get a number between -1 and +1, because those are the only numbers that make sense for the inverse sine. So now we can do inverse sine of answer. Again, if you hit that button, sine, cosine, tangent, you want to think about the mode. What mode should we be in for this problem? It says up here you want answers between 0 and 2 pi. That's a pretty clear indicator we're supposed to be in radian mode. So let's make sure the calculator's in radian mode before we hit enter. It is. And we get 0.895, right, 0.896. So from the calculator, t is around 0.896. That's how many radians it is. That said, generally when you're solving an equation like up here, if you have sine of t equals a number, and you're looking between 0 and 2 pi, there are almost always two different solutions. Just think about the graph of sine x, or sine t. And if I wanted the sine of t to equal, in this case, the value inside the green circle was 0.78. We'll just call that, yeah, okay, so 0.78 is fine. So if I put 0.78 right up there near the top, then you can see that that horizontal line hits the graph not just the once, which we just found over there is a 0.896, but it hits it again. And so we need to find that number. The calculator just can't give you both numbers. Inverse sine is a function, and you plug in one number, you will get only one number out, even though there are actually two different answers to our problem. So we need to think about using the symmetry. We know that this point right here is pi. We know that the distance from here to here, which is this distance down here, is a 0.896. Okay, my picture is not really to scale, but I'm hoping you buy into the symmetry that says that this distance going backwards must also be 0.896. So the other answer must be pi minus 0.896. We really need to think about the symmetry to get that number. So we do second pi minus second answer, 2.246. So we've got two answers, and I think we have no more between 0 and 2 pi. So the last thing I had said we would do was look at the graph. So I went all the way back to the beginning, not the quadratic equation, but before we even used any identity. And I'm going to graph both sides of that equation. So you can see the cosine of 2x on the top, and then the sine of x minus 1 on the bottom. The window, 0 to 2 pi, is good. Normally sine and cosine is -1 to 1, but because of this -1, I know the whole graph is going to get shifted down 1. So I just decided to go between -2 and 2. So there's my window. Again, we're in radian mode. Hit graph. We're really hoping that we see 2 points of intersection because we found 2 different answers down below. And that's comforting there. So we're looking for the 2 points of intersection. One of them is right around there, and the other one is over here. To find them, we do second calc. Choose option number 5. First curve, hit enter. Second curve, hit enter. Guess, hit enter. And in this case, it found us the right-hand point of intersection, 2.245, and change. So we saw that number before. And if you want to find the other one, second calc, 5. First curve, hit enter. Second curve, hit enter. And for the guess, you can either scroll to the left and just put the cursor somewhere near the other point of intersection, or you're welcome to type in a number that's close to that thing over there. For example, 0 is definitely on the left-hand side and closer to the first point of intersection. And then hit enter, and we get 0.896, just like we got before.